Welcome to The Explainer. Today we're going to pull back the curtain on something pretty incredible: how computers are learning to see. We'll be diving deep into how they recognize and classify images, all thanks to a really powerful technology called convolutional neural networks, or CNNs for short. All right, here's our game plan. We'll kick things off with what image classification even is. Then we'll peek inside a CNN to see how it works, check out the different types of classification, and wrap up by looking at where these things are already popping up in the real world. So, first things first, the big idea. What exactly is image classification? At its core, the idea is actually pretty simple. It's basically about teaching a machine to do something we do without even thinking. You look at a picture and you just know what's in it. That's the goal here, to get an algorithm to automatically sort a whole mess of photos into neat little piles, like cats, dogs, or mountains, with amazing accuracy. So how does it do it? Well, it's a three-step dance, really. First, the algorithm just looks at the image, taking in all the raw data. Then, it starts acting like a detective, extracting key features. Things like edges, specific textures, or recurring patterns. And finally, based on all that evidence it gathered, it makes a decision and slaps a label on it from a list of possibilities. Okay, that's the what. But what about the how? How do machines actually pull this off? Well, let's get into the engine room and talk about the powerhouse behind it all, the convolutional neural network. Yeah, when it comes to image classification, CNNs are basically the gold standard. They are a special kind of deep learning model that has totally changed the game. And the reason they're so good at this, they're specifically designed to process visual data in a way that's actually kind of inspired by how our own brains make sense of what we see. Whoa, okay, I know this looks a little intense, but bear with me. It's not as scary as it seems. What you're looking at is the journey an image takes. It goes in as just a bunch of pixels on one side, gets processed through all these different layers in the middle, and then pops out the other side with a label. We're going to break down the three most important parts of this whole pipeline right now. First up, we have what are called the convolutional layers. The best way to think about these is like a whole team of tiny specialists, each with their own little magnifying glass. One is looking only for vertical lines, another is searching for curves, a third is on the lookout for a specific shade of green. They scan across the entire image, highlighting where they find these basic, fundamental features. All right, after that, the data hits the pooling layers. This part is all about simplifying things. It basically looks at the maps created by the convolutional layers and, well, it summarizes them. It keeps the most important, most distinct features and gets rid of some of the noise. This makes the whole process way more manageable and efficient. And finally, everything comes together in the fully connected layers. This is really the grand finale. This layer takes all those simplified, high-level features that we've identified and puts it all together to make the final decision. It weighs all the evidence and says, okay, based on everything I've seen, I'm 95% sure this is a cat. And this is the real magic of CNNs. This is the absolute game changer. In the old days, you would have had to manually program a computer, telling it exactly what an edge looks like, what a curve looks like. It was a nightmare. But with CNNs, you don't do that. You just show it thousands and thousands of pictures of cats, and it learns on its own what features are most important for identifying a cat. It's incredible. Okay, so we know how the engine works. Now let's look at the different jobs it can do, because it's not just a one-trick pony. There's a whole toolkit of classification types. And you can see just how flexible this is. You've got your basic binary classification, which is a simple yes or no question: cat or not cat. Then there's multi-class, where the image has to be one of several options. Is it a cat, a dog, or a bird? Then it gets even cooler with multi-label, where one picture can have multiple tags, like beach, sunset, and palm tree. And finally, you have fine-grained classification, which gets super specific, like telling the difference between a cardinal and a blue jay. All right, this has all been pretty techy, I get it. But why does any of this matter? Let's talk about where you can find these CNNs out in the wild, because they are everywhere. Look at this list. We're talking about life-saving applications in medical imaging, where they help doctors find diseases on X-rays. They're the eyes of autonomous vehicles, spotting pedestrians and traffic signs. It's the facial recognition that unlocks your phone. It's in e-commerce, letting you search for a product with a photo. They're even used for environmental monitoring, like tracking deforestation from space. This stuff is real, and it's happening right now. So, to kind of wrap this all up, it's really important to see that image classification isn't just some cool niche tech. It's truly a foundational piece of the puzzle. It's one of the key things that allows machines to begin to interpret and, well, understand the visual world in a way that's getting closer and closer to how we do. And because it's all driven by deep learning, the list of applications is just going to keep growing and growing. It's already transforming entire industries, which, leaves us with a really interesting question to think about. What's the next big, seemingly impossible visual challenge that we're going to teach computers to solve?